the panel discussion for day 2. It's about the history of science and its coming of age. And it's a very, very exciting topic. And I'm sure you're all very, very interested to know more. So I'm going to hand over the mic to Banya. Banya is a science communicator and public engagement practitioner and has been associated with us for the past few months and has moderated various events. Banya, thank you for joining us here today. It's such a pleasure to host you at ISF once again. And with that, I would request you to take it forward, introduce our panelists, and take the session ahead. Thank you so much.
Thank you, Shruti. Very happy to be joining everyone at the India Science Fest 2022. Hello, everyone. I trust you all are doing very well today and staying safe. I welcome you all to today's panel discussion, where we will delve into the history of science and its coming of age, especially in the Indian context. Study the past if you would define the future, said Confucius a very long time ago. And this is what we will try to do today by investigating the history of science, its evolution through the years, how global interactions, conflicts, exchanges, and changing times and conditions have shaped science, its practice, and more particularly its development, and how we can draw from learnings of the past to address challenges of the future. I really hope that we all will be able to catalyze great conversations today as the most extraordinary selection of panelists join us in action. I welcome Jahnavi Phalkey, a filmmaker and historian of science and technology. Formerly at King's College London, Jahnavi is now the founding director of Science Gallery, Bengaluru, and Sir Ashutosh Mukherjee, visiting professor at the National Institute of Advanced Studies. Jahnavi has explored the history of science in India extensively and has authored Atomic State, Big Science in 20th Century India. She has also co-edited Science of Giants, China and India in the 20th Century. She is on the editorial board for the British Journal for the History of Science and History and Technology. She is the director-producer of the documentary film Cyclotron. Thank you for joining us today, Jahnavi. We also have on the panel Dhruv Raina, a leading philosopher and historian of science in India, best known for his work on domestication of science in colonial India, transnational intellectual networks of science, and historiographies of science. His research has focused on the politics and cultures of scientific knowledge in South Asia. Over the last couple of years, he has been working on cultures of history and science policy in post-colonial South Asia and the social theory of science and mathematics. Currently, he is a professor at the Jawaharlal Nehru University, New Delhi. Dhruv has co-edited Situating the History of Science Dialogues with Joseph Needham and Social History of Sciences in Colonial India, and more recently, Science Between Europe and Asia. He has co-authored Domesticating Modern Science, a social history of science and culture in colonial India. He has published extensively on related subjects in journals of history and philosophy of science, social studies of science, and social and political history. Welcome, Dhruv. I hope you'll enjoy your time with us today. Also joining us today is science journalist and author Hari Pullakat, who won the Indira Gandhi Prize for Popularization of Science in 2020. He has spent 3 decades of his career writing for the Economic Times and Business World. He is the editor of Shaastra, a science and technology magazine published by IIT Madras. Hari's recent book, Space, Life, Matter, The Coming of Age of Indian Science, brings to readers the path-breaking contributions made by India's scientists to original research and what they mean to the nation's progress. It is the celebration of the achievements of some of the enterprising scientists and under very trying circumstances who have tried to build the science infrastructure of India from scratch. Welcome to the panel, Hari. I will open the discussion with specific questions to each of the panelists based on their field of work and interest, and then steer the conversation to topics of broader interest. We welcome questions from our audience, which we will take at the end of the discussion. Therefore, I request our audience to please keep dropping their questions in the chat box for our panelists. And now, diving straight into our discussion, I'll perhaps start with Jahnavi. Jahnavi, based on your previous work, I wanted to explore with you and compare the development of science, specifically in India and China. I have a sense that in the 1980s and the 1990s, science done in India was viewed to be more mature and better developed than that was in China. However, the situation seems to have changed, and it's very different right now. If we go by any of the standard indicators of science and research, it seems like China seems to have shot far ahead. In some niche areas, China now appears to be a world leader. If I want to give you an example, let's say the fabrication of samples in condensed matter physics. The same trend can be seen in higher education also, because some of the universities of China are well placed in world rankings in comparison to the educational institutes of India. So, and maybe this was not the case 25 years ago. Is this correct? And do you agree with what I just said? If so, what would you think accounts for this change in this trend? And what lessons can India learn from China, or the policymakers in India can learn from China?
Thank you, Banya, for the question, and thank you again for the invitation to join you all this evening. So I'm a historian of the 20th century. Largely, my expertise lies in the middle decades of the 20th century. So already by the 70s and 80s, I feel a bit shaky. So I think whatever I say should be taken with a pinch of salt. That said, the collaboration that I led with my colleagues, were about 18 of us, nearly half historians of China, historians of India, and we worked together over 5 years. I can share some of the learnings that, from that project and what our observations were. And I've often discussed this with a colleague of mine, Arun Abghosh, who teaches Chinese history at Harvard, is that there is a larger story of 20th century developments in science and technology in China and India, which needs to be written, and it's not yet written, right? Like we do need, Dhruv and Hari can, add to this. We do need better archives to be able to write the story of the 70s and 80s, and we don't have those archives actually ready at hand. So whatever I say will be tentative, and it will be from observations from earlier decades and what we've learned, by interacting with people. So there was a divergence in the early, one can say broadly, there was a divergence in the early 20th century, which kind of came towards a conversion in the middle decades of the 20th century. But the divergence again that you're talking about, and there is one, there is no doubt about that, begins much earlier. It begins in the 70s already. Right. And 70s decisively. So it's not that, the divergence kind of gradually happens after the 70s. It decisively begins in the 70s. And a few things that one can actually point towards historically are as follows. So the 12-year science plan that the Chinese government embarked on. So remember, 47, 49, right? Like those are the years in which the modern nation states of China and India, in a sense, begin to participate in a global sort of model economy of science in a specific manner. That doesn't mean they weren't there before, obviously, but they begin in a specific manner in 47 and 49, respectively, for India and China. And the first Chinese 12-year plan comes already in 1956. And there are archival documents on the Chinese side which show us that the Indians actually wanted to look at the plan in 1956. Mm-hmm. They were not allowed to see the plan at that point of time. And the first science plan, so to speak, for India came as late as the 1970s with Mrs. Indira Gandhi. And that plan was shelved because the plan was, in fact, the implementation on the plan began during the emergency almost. And was shelved with the incoming new government and never taken up after Mrs. Gandhi came back to power again. So this is not to kind of place causality as the doorstep of a science plan, but this is to say that a concerted effort at integrating scientific research and education into larger questions began in a very, very decisive manner in the 50s in China. Remember, implementing a plan in 1956 would mean that a lot of thinking would have to happen before that.
Yeah.
Right. And so that began there, and it was a 12-year plan, not a 5-year plan. So the understanding that the horizon to change the landscape of research and its sort of concomitant relationships to other aspects of organizing education, for example, or patents, etc., was understood to be a far more long-term process than, say, a 5-year plan would allow. So so in many ways, in the absence of proper archives to study this, in fact, also on the Chinese side, it's quite patchy. The archives are available, but it's patchy. Access is patchy. So what we can say is that you can say that in the mid-50s, the divergence has already begun, right? And the heavy investment in education, the heavy investment in laboratory research, in terms of funding, in terms of bringing back people, giving them research, and scholars such as Mark Walker have drawn a distinction for the Soviet Union, and I think one can tentatively extend that also for the Chinese case, which is a distinction between political freedom and scientific freedom, where you bring in people back from, so what are called return migrants, right? Like people who've gone to the United States to study, being brought back, often actually under duress, maybe, or even under political pressure, but they are given the freedom in the lab to do a lot of things that they might actually want to do. So in a sense, the interference is there, moderated more than the political freedom is moderated, right? And so one can say that those circumstances have allowed Chinese science, engineering, education, and research to develop in certain ways. Now, how does it exactly compare? So what we did, as historians, we still were focused very much up until the middle decades of the 20th century. So anything after that would have to be studied far more carefully. And I think it is studied at this moment by policy scholars if the assumptions that policy scholars have are different to the assumptions that historians have, right? Like we begin with fewer assumptions. And in a sense, we don't set out to prove an observation, but rather actually set out to make an observation, right? And so I think that still needs to be done, but there's no doubt that there is a divergence, and that the roots of that divergence can be patchily traced back already to the mid-1950s. So that is sort of a slightly tentative answer to your question.
Thank you, Jahnavi. If I can just add a question to that, if I were to invite you to maybe point out at one or two things that may have happened in China during these years, from which we could take back a learning and we could implement similar structures or similar infrastructures in India for a better scientific development in the country. What would be your first 1 or 2, 3 takes on that?
Yeah. So, again, I think Dhruv will bear me out on this. As historians, we look for specificity, right? And we seldom sort of draw very broad generalized lessons. That having said, I understand the nature of your question and where it's coming from. And what I would say is that I think what this calls for, without a doubt, is without a doubt in my mind, is better investment in science research. Better investment in Indian universities. And this is something Dhruv has written about fairly early on, that, our universities are underfunded seriously. I mean, we have money being poured into national institutions of national importance, for example, or national laboratories, which are sort of the preferred form after the Second World War globally, but not to the detriment of Indian universities, to the detriment of universities elsewhere, but that has happened in India. So I think without a doubt, I can say that, say this much, that better funding, better organized funding for universities, a better sort of organized funding agency structure, like the National Science Foundation, for example, or the Research Councils of the United Kingdom and other European agencies, etc. So independent bodies, peer-reviewed bodies, better organized, better peer-reviewed, etc. I think there is no doubt that that needs to come in, and that needs to come in across the human, natural, and social sciences. It's not a question only of natural sciences and engineering, and I think that needs to come in without a doubt. I'm not saying this exists in China, but what I'm saying is that they did pour in money in a manner in which the political economy of China was served. And here, I think we would need to look at what would work for structures here, for people here, for the kind of existing infrastructure we have. And I think putting funding into universities is something that's long overdue. And ITIs, sorry, the other thing. So like my favorite statement, and I think I'll repeat it until people ask me to shut up about it, is to pour as much money into the ITIs as you pour into the IITs. And that's when we will see a difference in outcomes.
Thank you, Jahnavi. Dhruv, would you like to add something to that? You are on mute. Yeah.
Yeah, no, I mean, no, I quite agree with, and I think I have quite a bit to say about the latter part. Yeah, I mean, China's commitment to developing their universities and their science and technology over the last 3 decades has left India far behind. There is no ground for comparison. As Jahnavi rightly pointed out, there was a common ground. Probably India was a little ahead in the 1950s, but I don't think there is a viable comparison any longer. We just need this. Yeah.
And that quite nicely brings me to the question for you, which is that even though science was relatively a very small scale affair in India in the early 1900s, it produced some very notable results. For instance, J.C. Bose's pioneering experiments on sensitivity of plants to external stimuli, or experiments with radio waves, the Shah equation, which were discovered in 1920, the Raman effect in 1928, all of these major developments had a global impact. And this trend also continued for some time after independence. But if we look at the last 50 years, in contrast, Indian science has become a much larger scale affair. If we talk about the infrastructure, the funding, but we do not, maybe we did not see such notable accomplishments of maybe global impact. Is this accurate? Is this an accurate observation? That's my first question. And if so, can you suggest an explanation or dissect the possible explanations for this trend that is being observed?
Thank you. I'm not sure, I mean, if I have a credible or a satisfactory explanation. But this whole way of looking back at the history of modern science in 20th century India is framed by a discourse of what I would call science and nationalism. And also by a trope, one might call the trope of the rise of science and the stagnation of science, in which there are heroic figures. We announce their contribution to the advancing frontiers of knowledge, and then we have practitioners who carry on the tradition, or in Veblen's language, rantiyas, who live off the benefits of the tradition that's so established. Yeah, but I would like to respond to it. As I said, I don't have a credible explanation, but I would like to respond to this at 3 levels. One, institutional, and the other 2 has to do with the imaginary we have of science and the role historians of science can play in changing that imaginary. So I want to tell, we need a story which is less about individuals, but more in terms of major institutional transformations in the world of science after the Second World War that changed the practice of science irreversibly. All right. And once that happened, the independent Indian nation state was drawn into playing what you might call catch up with me. right, catch up with the West. You were drawn into that game. Now, I think Jahnavi has also hinted towards it, that though India was a model nation, it was in fact a model nation. I saw it when I visited the International Center for Theoretical Physics in the early 1990s. When you talk to people from other parts of the third world, they said, in India, you've accomplished a lot. So it was a model nation for the developing world in terms of its investment in the world of science. But however, with the wisdom of hindsight, one could argue that those investments were suboptimal to keep pace with the investments of the developed world, right, in the sciences during the Cold War. The Cold War was a great driver of investments in the sciences. So while the investments were substantial in developing world context, I don't study the economics of science, but I think the figures will bear me out. So while our investments were substantial, all right, they were not enough, to borrow a term from the 1950s, Bhabha and Saha used it, leapfrogging. They were not enough to catch up with the accelerated frontier of science in a global context. All right. I mean, the institutional transformation was so difficult. It was not like Rutherford doing experiments in nuclear physics in his lab with candle wax and, string. It was another kind of science. All right. So that's the institutional backdrop we must keep in mind. And I think India's over the years has to do more and more work to keep abreast with the advancing frontier of science. Right. But from there, I'd like to move to another question. I mean, and that is, it's something historians of science have confronted, especially when you're talking about the post-1950s era. It becomes very difficult to write a national history of science. All right, because we have now lived through a century where the world of science has witnessed increased internationalization. So in addition to the people you named in your question, there are so many other people you could name, and then you wonder, where do you put them? Where would you situate somebody like ECG Sudarshan, for example? And the debate surrounding him is, here's somebody who's missed the Nobel Prize twice. Or where would you put the work of the statistician C.R. Rao? They did some of their work in India. They did much of their work abroad as well. I mean, where would you localize them? Where would you tell their stories? So there is the problem of the localization of the work of individuals and their institutional belonging in India, albeit they belong to very specialized niches of academic excellence, like the IFR or the Indian Institute of Science or whatever. All right. So these were the niches of excellence. So, I mean, where do we don't count them. They become kind of homeless individuals like this. All right. And so I think, in this list, we have a pantheon, and there are many, many people who are not part of the pantheon. So the pantheon looks rather thin. All right. So this pantheon has acquired a certain sanctity in the imagination of science. It starts with J.C. Bose, Acharya Prafulla Chandra Ray, one of my heroes. There's S.N. Bose, and we know that. But from the post-50s era, I mean, how many biographies, you tell me, how many good biographies have you seen of somebody like G.N. Ramachandran, who played such a phenomenal role? One of his PhD students was my colleague, and I often told her, she's now retired. I said, if you don't write the biography, who will? All right. Or how much work have we seen on, except for some papers written on the subject in the 1970s, and one PhD thesis on the work of Shashi Shekharan and left-handed DNA. Mm-hmm. Right. Now, I don't want to give you an exhaustive list of people who are excluded, or an alternate list. All right. But what I'm trying to say is that those included in the pantheon have to be there. But we need to recognize that they were not the only ones. And when you do that, the question begins to change. Yeah. So it becomes ethically binding on the historian of science to look at the past of science with a finer lens. Yeah, I think I've gone on long enough, but I think there's one last point, which is a rather important point. that, most of the people in this pantheon have made contributions using an older vocabulary of science policy, have made contributions to the pure sciences. Most of the people included in the pantheon were physicists, even people like Sarabhai and others, all right, who lived through the golden age of physics. And because they lived in the golden age of physics, we seem to neglect so many other fields. Right. But what about those who are working in, and I use the term parenthetically, who are working in the lesser sciences? Mm-hmm. Right. Except for some papers by Abhasur, how much do we know about Anamani, a leading meteorologist? How much one book on Janaki Ammal, and how much more do we know about her? So what happened to all our women scientists? Were they not there? Of course they were there. Have we talked about them? Do we put them in the pantheon? No. All right. And then in all of this, we never speak about the engineering sciences. All right. Looking at Hari's book, one can see that, there's a very important role for the engineering sciences there. Have we talked about it? Have we talked about those? Have we talked about the Nayodamas? Have we talked about the Satish Dhawans? We have talked about them in specialist journals, but they are somehow not part of the iconography of the imagination of modern science, of science in modern India. All right. And then, of course, what about agriculture? I remember in the 1980s when I came into the world of research, everybody was talking, India is a developing country, 70% of the Indians live in the rural areas, agriculture is so important. How much do anybody other than those working in agricultural science know of the work in agricultural science in India? Were there no heroes there? I find that deeply unlikely. Has anybody in the audience even heard of the names of D.L.N. Rao or Ratan Lal or any of these people? The point I'm trying to make is, we have posed the question. It is a question so often posed. I'm actually tired of the question. But the problem is not then, what I'm trying to suggest is the problem is not with Indian science. Mm-hmm. As it is with our conception of science, which is not capacious enough to look at science, which is pursued in so many other directions which we've not cared to look at. All right. I never thought actually, that, I would be on a forum like today where I would end up defending Indian science. I never thought I would ever be doing that. But I think today, particularly in today's context, it merits far better treatment, right? And the role of the history of science in revealing this context is probably one of the best steps forward in that direction. I think that's all I really have to say. But I think these would be the three axes along which we could explore the problem.
Thank you. Thank you for explaining the different phases of that discourse and that problem. And I would like to extend this question to both Hari and Jahnavi. How do you see that we can change this discourse, or we can change this notion that has made a place in our minds?
My answer is very quick. I second what Dhruv said, which is I think we need better histories, better narratives. We need to pay attention to what has happened in all its, what's and all. But I think we need a better understanding of, as I think George Perkovich said that in the introduction to his book on the Indian bomb, which I used for, as a starting point also for my work, which is that what are the decisions taken in the past, and therefore what are the choices made, what are the consequences of those choices, and therefore where are we moving now, right? And in order to understand that, we need to, in a way, understand those decisions in their context, not to say that was wrong or that was right, but to say this was the rationale behind X choice, and the consequences and the costs of the decisions are X. And that would be a good way to move forward, right? So I think, the fact that, Dhruv and his colleagues have been struggling for decades to get a history of science program get going in an Indian university. We don't have a single university offering a degree program in history of science, history and philosophy of science, sociology of science. Of course, there are people in various departments, students of Dhruv and people like myself who've come back, after training elsewhere. But there is no concerted critical mass of scholars where we are training people properly in methods, in setting up archives. So there's no infrastructure to do this kind of work. And I think that would be a good starting place, really. A very, very essential place.
Thank you, Jahnavi. Hari, would you like to add to that?
I don't have much to say. I think both of them have said what it needs to be said. And in any case, I'm not a historian. I'm a journalist. I just happen to write a book. So.
Yeah, but you have like chronicled the scientists and their journeys and how that have shaped the infrastructure of the Indian science enterprise in India, and that's a great piece of work. And because of this work that you have done, I think the next question that I wanted to ask you was that, what do you think about the role of institutions in the growth of Indian science? Because in your book, you have touched upon how the journey of specific scientists have led to the foundation of the Indian scientific enterprise and the institutions in India. So would you like to talk about the role of institutions?
Okay, so let me elaborate on that point that I'm not a historian and I'm a journalist. And as a journalist, I'm interested in people. I'm interested in people as scientists, as individuals, how they work, what are the problems that they face on a daily basis, and how do they solve them. I'm as much interested in their emotions as an individual as I am in the science that they did. Of course, I would like to see good archives, and I did try very hard. I couldn't get much. But then my book is constructed through interviews. And that's my primary source of information, talking to people at great length. So if you look at the people that, in the early days, like from Bhabha onwards, I have not met them. I have not read that much about it, but I have talked to people who worked with him. I've talked to his students, and sometimes for very, very long conversations. So whatever I know is from those conversations, not so much from going through archives. So in terms of about TIFR, what I have to say is, I think Bhabha wanted to set up an institution. First of all, he was not trying to set up a big institution. His main aim, as far as I understood, was to have an institution where he could work in the way he wanted. Indian Institute of Science had its own problems, and it was not doing the kind of research that he thought India should do. And he could not change the culture of the institute. It has already gone through a very turbulent phase. The first director itself had to resign, and then later C.V. Raman had a lot of problems. So it was a problem-ridden place. And in his opinion, it did not have the equipment or the culture to do modern physics that he wanted to do. So he thought he could set up an institution. He knew people, and they gave him money. And what he set up was sort of a model institution. And TIFR became a model because it had things that nobody else had, no other institutions had. It was a good place, a good office, centrally air-conditioned, good locale, but people have all the freedom to do what they wanted. But it had only physics and mathematics initially, and then it grew. After that, there were some other institutions like NCL, and then later in biology, some certain departments which became sort of pioneers. But I don't think there is any TIFR after that, this kind of same scale. In terms of institutions become model institutions, I don't think there was anything else after that. CCMB and biology. That's all.
So if you look at these model institutions, if you in your experience of reporting about the science done at these institutions and the work taken up at these institutions, what is the major difference that you find between these model institutions that you just mentioned and the other scientific institutions in the country? What are some of the key lessons that you would say that can be learned and implemented from these model institutions?
So the first thing is what Jahnavi said earlier. They have money, at least relatively speaking, because they had a charismatic person at the top. TIFR, it was Baba, and in CCMB it was PM Bhargava, and in other places, and every one of these institutions, they had somebody who had some access to funds. So all these institutions had money, and if you have money, you could do things. And the lesser known institutions, there was nobody to bring the money. So this is a single most important difference. And of course, there were some cultural issues, like they had more freedom to work. They were more open place. But the most important thing, in my opinion, is money. Whatever I have seen is, so if you have access to funds, you could do more.
And while we look at the current scientific enterprise in the country, or the current trend of how science and research is done in the country, do you see a particular trend in these institutes or universities that could be particularly beneficial for the Indian science infrastructure?
I don't think I fully understood that question. Beneficial to Indian infrastructure? What did you mean?
I mean, any particular trend in that you see in these institutions, in these model institutions, or in the science culture in India right now, that could be helpful for the development of the scientific infrastructure in India? Apart from, of course, more funding and for research.
I think the most important thing is still money. But what has happened in the last 20 years, that is noticeable trend, is the rise of IISers and IITs, especially IITs. IITs have the research output from IITs has substantially increased. And the quality of research from IIT is also significantly high. And they brought engineering to a level which was not in the, we had in India, the most visible aspect of Indian science was chemistry, through the for a few decades after independence. Biology started in the 70s, and then through the last 20 years, there was a lot of, but from 2000 onwards, IIT started publishing, and the rise of engineering as a research discipline is the most visible thing on Indian research that I have seen. And that has come from IITs. And IISers is also doing very well. Some of the IISers are now giving a run for the money to the IIC in terms of the research that they're doing.
Thank you, Hari. I think that I'll go back to the discussion that we had on archives that Jahnavi had picked up and also Dhruv had picked up. There are several scientific institutions in India today, and several of them have their own archives. Do you think that these institutions should also offer courses on history of science? And why is a course on history of science very important today in India? Your take on this. Jahnavi, would you like to respond to that?
So could you just quickly say what you were saying again, just the last bit?
Yeah, so do you think that these institutions with archives should introduce courses on the history of science? And why do you think that it's absolutely necessary now, maybe to have courses on history of science in India?
Yeah, so I don't think there is a necessary correlation between having an archive and having courses in history of science, right? I think archives are maintained by essentially So what do we as historians of science study? We study the processes of knowledge production, right? The process by which science is done and how it's embedded deeply in society. And so the archives are spread all over, right? And the archives might not be necessarily institutional archives. They could be personal archives. They could be, in many other places. And so they needn't. So courses in history of science needn't necessarily be offered by those institutions. In fact, history of science is a relatively young field, and I think Dhruv will be able to say much more to that than I can. But what I will say is that it did start out in this manner, that history of medicine was taught in medical schools, for example, and history of physics was taught in physics departments. Now, that's not to say that shouldn't be done. In fact, that should be done. But I think history of science is also a field in its own right now, and it has existed for a long enough time. And I think it needs to be allowed to prosper and thrive as an independent discipline with a critical distance from the practitioners of science. And therefore, the archive holding institutions are essentially materials from which we write our histories. We needn't write them in those institutions themselves.
Okay.
We could be at a distance. We should definitely be at a critical distance. We may or may not be in those institutions or not. But the infrastructure to be able to do that, right? To train new generations to be able to do that. And again, archiving is not something that historians do themselves, right? I mean, there are professionals who do archiving. And we as historians go and access those archives, right? And so there's infrastructure. Those are two complementary, supplementary, essential things for each other, but they need to be grown separately. So there should be proper archival training. There should be proper collections policies. There should be proper sort of guidance on how to maintain those institutionally and otherwise. Personal papers of people need to be acquired, etc. All of that. So that needs to continue. So so there are two professions here that we're talking about: that of historians of science, engineering, medicine, environment, etc., etc., and archiving, right? So archivists and the supplementary things that go along with it. And it's essential, to do this, and just in a couple of sentences, because effectively, we don't know why we are where we are. And if we don't understand that, any decision that's taken is in a way, we are unable to understand the archaeology of the layers upon which the present condition rests. And unless we're able to analyze that, any step forward is a blind step in many ways, right? So our assessment of our present is incomplete if we don't understand how we got there. And if we don't understand how we got there, then anything that goes ahead is going to be on equally shaky ground and very tenuous. In fact, decisions taken earlier probably were on less shaky ground than we are now. Because, I think historians of science, probably of a generation even earlier to Dhruv's, right, had colonial archives to rest on to understand in many ways the decisions, right? And so, and this is not to say that history of science should feed only into policy. I mean, it's also about understanding, developing a critical public debate on science, for example, right? What is the public space of science? What is the public function of science? What is the place and space of science in Indian society, in Indian political economy? I think an understanding of that, or an informed public debate on that, can emerge only when we understand where these decisions are coming from. And, what are the consequences that we are living with of decisions taken in the past, be they about education, be they about research, be they simply about public discourse on science, right? And we know it is a highly contentious discourse. So I think history of science is as essential as history is, right? Like, it would be the same reason why bother with history, and we know why we should bother with history. And therefore, if science matters to us, then we need to know the history of science as well.
Dhruv, would you like to respond to that? And we have a very interesting question from our audience also, which is in a way connected to this discussion. During pandemic, I got to read a lot about history of science and got inspiration to be a scientist, and also understood how scientific investigation is done. Why isn't history of science in school curriculum today? I think you're in mute, Dhruv.
Yeah, all right. Yeah, I'd like to reiterate some of the points from a different angle that Jahnavi has made and then come down to the question.
Yeah.
No, I mean, very specifically to the question, I think, yeah, institutes want to run courses in the history of science, they should run it. I don't see why not. Perhaps they should. But the salient question is, when you decide to run a course, what role do you envisage for the history of science? Why are you doing history of science?
Mm-hmm.
Is it celebratory and triumphalist and to glorify your past? And I mean, and in that sense, it's not that it's unimportant, but, just like the question has come from the audiences now, yeah, people are inspired to do science when they read such works. Sure, it's important. But then we also want to understand the dynamics of the growth of scientific knowledge, the relationship or the place of science within culture and the relationship of science in society. Science is part of culture and science is transforming culture. All right. I mean, there were historians like Joseph Needham who said that, by enriching the memory of the past of science, we are also in a way contributing to the future of science. All right, in many parts of the world, in Germany, for example, history of science also contributes to science education. The construction of scientific experiments is then brought into school teaching of classical scientific experiments. So it has a role in didactics. All right, it has a role in the conceptual clarification of present ideas by turning to the past. Bertrand Russell, in his introduction to the history of the philosophy of mathematics, said that. All right, so if it is to be all of these and just not the first, that is the celebratory aspect of the history of science, if it is to be all these other things, then the identity of science, as Jahnavi was saying, cannot be parasitic about the scientific community. It has to have an agenda that goes beyond the scientific community. And this is something I've been arguing from my papers from the early 1990s onwards, that the history of science must not be parasitic upon the sciences. It has to have a separate and an autonomous existence. Now, one of the failures, Jahnavi rightly pointed out, of my generation of historians and philosophers of science and that preceding mine was our inability to remedy the weak institutionalization of the history of science in India. Or, only recently I was called to give an inaugural talk at the creation of a department of the history and philosophy of science created by philosophers. In the Center for Philosophy, you created a space for the history and philosophy of science. So we know where the focus of investigation will be. But it is important to note that the historiographic revolution in the history of science, which my generation was sort of born into, we grew up, inspired by that in the history of science in the 1980s, was informed by developments in what you call social theory and philosophy, which was at the conjuncture of anthropology, sociology, gender studies, anti-race studies, transcultural history, history of ideas. All right. Philology, because we're not just studying the present of science, we are studying the very ancient past of science, we are studying the medieval history, we are studying all these periods, right? In a science institute, your focus could be, a research institute of science could be the present of science and the present of the people who are at your institute. All right, and these developments in the history of science then goes on to transform even social theory. It alters sociology, it alters history. See, for example, Zoe Todd's recent work on indigenous knowledge, for example. Now, so I think, therefore, the natural home for the history of science is the university. And I'm in total agreement with Jahnavi. I believe that. But I think that the IITs have attempted in some way, they have tried in some way, to capture the flavor of what we call the humanities and social sciences, and to the extent possible, nurture history of science within the IITs, to the extent possible. The IISers are trying them in their own way. But getting back to the research institute, so for example, a legendary historian of physics, Spencer Weird, was a historian of science associated with the American Institute of Physics. All right. And the richness of his contribution, you can see, is a reflection of his widespread and expansive training in this interdisciplinary field, which is the history of science. He wasn't trained at a research institute, right? History of science is an interdisciplinary field. So the answer to the question is, what do you want to do with the history of science? And today, I think, for example, we entertain the possibility of the history of sciences enabling a dialogue between the sciences and the social sciences, of disclosing conceptual linkages between the sciences and the social sciences. All right. A lot of this work is long-winded, time-consuming. The scales which only a university can allow for, not a research institute. All right. But then, I'm going to get into my favorite hobby horse, like the importance of history and philosophy of science there, but no, I'll stop here. Yeah.
Thank you, Dhruv. We have a very interesting question coming up for Hari.
Just one sec. So the question is that school textbooks do it badly, but they do try to address the history of sciences in little blocks on the history of science inserted in the text. They recognize its importance. It's not done well enough. Yeah.
Yes. So coming back to the question for Hari. So what inspired you to write Space Life Matter? Why did you decide to look at the Indian science and bring those experiences in the form of a book?
So let me add. It is related to what I was wanted to say about what both of them said. Apart from academic study of history, and what interests me is I read a lot of popular history. I don't read academic history, and I'm not an academic historian. Sometimes I do read, and unfortunately, we haven't had popular history in science in India. So, especially scientific biographies. So, Dhruv mentioned that there should be a biography of GNR. So, there are at least 4 or 5 scientists in India who've done enough to merit a good biography, which is also a bestseller. But far from being a bestseller, it has not even been written. So why is that? I think it's partly because books don't sell that much in India, and it's very hard to make a living writing books. Professional writers need to sell books to make a living, and only then will they have the time and the money to invest in a project. To write a good biography, it takes 2 to 3 years, and unless you get at least some return on that investment, not the full thing, at least, or at least you have the satisfaction of people having bought the book and read it in enough numbers. You don't get inspired to write such books. But I think as the market develops, we should see such books more. Now, coming to what inspired me, it was just a very, very accidental thing. Somebody asked me, whether I have a book idea. I said yes. I couldn't say no. I had been thinking about this for at least 10 years now, but I had not written anything. And then I wrote a proposal, sent it to the agent, and I got offers. And I really started thinking about the book only after I signed the contract. And it took me a year to figure out what I should write. I only knew that I wanted to write about this period, something about these people. So that's how the book happened. And looking back, at least the final part of the book has been done in a hurry, because the COVID, by that time COVID had started, and the book was sort of an unfinished thing in many ways in my mind. So there is no inspiration as such that I can think of. Except some individuals, but that would not have resulted in a book. I signed a contract, so I wrote a book. That's it.
Thank you, Hari. Both Dhruv and Jahnavi are also authors here. And I would also like to extend this question to them. What inspires you when you think about writing the book? How do you go about it?
You want me to answer that? No, inspired. I don't know. I don't like thinking in terms of epiphanies. All right, but yeah. But despite that, I think there's an interesting problem. One is my writing has been fragmentary. A problem interests me, I write a research paper. At the end of some time, I think, all right, I've written up 10 papers on this. I put it together as a book. That's the way I write a book. All right. I mean, I don't write, I choose a problem. No, there are little fragmentary problems that I look into. I'm that kind of a researcher. Right. And then I put it into, when I begin to see that a theme has been built around the little fragmentary problems I've addressed. But there are people who have a book on a subject in mind. All right. Like you want to do a history of physics. I don't work like that. I mean, I'm interested in small, little problems, and I see them building up into something bigger at the end of it. And then I cobble it together. Okay. That's all. I don't have an epiphany.
That's a very interesting process. Jahnavi, would you like to add?
Yeah, so I mean, I haven't written as much as Dhruv has. I have one monograph, and I have a couple of edited books, and then a few papers. Why do I write, or when I have written, why have I written? There are questions that nag at you, right? Like, what is this? And so my first book, which developed, which in fact came out entirely from my doctoral thesis or doctoral research, was when, I was sitting in 20th century history of science classes, Cold War history of science classes, and I would be like, okay, what was happening in India? Why don't I know anything about it? Why, so it was like, okay, the most interesting middle decades of the 20th century question is about experimental nuclear physics. And I was like, okay, what were the Indians doing? Right. And so I wanted to chase those labs and find out what they were doing. Right. And I wasn't interested in the bomb. I was interested in experimental nuclear physics, because, that in a way would make anything possible. Right. So the bomb itself was uninteresting also because there's no archive to write, no proper archive to write from. And so for me, it's questions. So the India-China project also grew out of that question, right? It's like, okay, we've talked about India and China together so much. And those were, the last decade was when, again, we were talking about it a lot. So it's like, okay, what are those stories and how do we compare, right? And so basically, a colleague of mine and I put together a group of, about 18 of us, half working on India, half of us working on China. And the experiment was to write those papers together. So for example, the paper that I wrote was about the first Indian plan, which I spoke about, and my colleague wrote about the first Chinese plan. And the volume, of course, covers several areas, the tiger project, the snow leopard project, the panda project, whatnot, and coal and this and that. So range of questions then, that we consider. So again, that question was, okay, so why, when we are talking so much about India and China, how do they compare, right? In history of science, but the interest was not so much policy. The interest really was in history of science. So things like that, right? And I'm numbers, for example, Dhruv already spoke about C.R. Rao. Where do you place C.R. Rao in the story? Or where do you even place Mahalanobis in that story, right? Mahalanobis is known for his work on the Planning Commission, the National Sample Survey, but in the 50s, for example, India was at the forefront of sampling technologies, thinking statistically about the problem of scale, right? Which both India and China confronted, and they are addressed very differently. So for me, the starting points are questions, and although I've come around now because I'm in a very different situation, I'm not in a full-time academic job as I was until 4 years ago. And so now I don't have as much time to, pull things together. So I think I'm moving more towards how Dhruv works, which is to think of, writing maybe smaller papers and then seeing how they might come together. But I do think monographs. They're not epiphanic in any way. I absolutely do not know the answers before I start, like most of us historians don't. But I even when I thought about the history of statistics project, I could actually see the chapters. Or when I was working on the aeronautics project, I could see the chapters. I decided not to write that book eventually, and I've written one paper. I'm probably going to write another one and then finish it off. But yeah, so it's often questions that bother you. It's like, okay, how, why, yeah.
Thank you, Jahnavi. We have questions pouring in from the audience, but unfortunately, Shruti has just given me 3 minutes to close. So we'll just be taking concluding remarks from all of you. And Hari, just your concluding message, your concluding remark for our audience.
I hope people buy science books and read. And I hope people write good biographies of Indian scientists. You have a model here, The Man Who Knew Infinity by Robert Canigal and Ramanujan. we should have biographies of a similar quality on C.V. Raman, on GNR, on J.C. Bose, S.N. Bose, and all those people. I think that is my wish.
Absolutely. I second that. Dhruv, your concluding remarks for our audience?
Yeah, no, I mean, the pursuit of science is very exciting. The pursuit, I'm not sure that we can learn lessons from the history of science about the past, in the sense that as science goes, we are also altering our future. So we don't know how much we can predict and how much we can learn. But just the growth of science is so exciting. But also how science changes society is so important. And it is so important. And I think telling that story requires a whole new set of skills, and also requires a vision of a connected world. And today, I think when we look as historians of science, we need to tell stories of how the world is connected, all right, and how ideas are connected. That's the story we need to tell. Yeah.
Wonderful. I don't think I can stop that. I think that was fabulous. I mean, I think that message needs to be reiterated for all sorts of reasons. The connected nature of our world, and why thinking about these stories might matter, actually. So just a small footnote to that, which that message needs to be reiterated. Small footnote to that, to say something again that Dhruv said earlier, which is understanding science in context, science in culture, science as part of culture, and science as transforming of culture. And therefore, the need for a very strong dialogue between the human, social, and natural sciences, and of course, engineering sciences, I'm just kind of bucketing them together, is very, very critical. It's absolutely critical today. And I think that, that needs to happen, that opening needs to happen, in order not only for us to write better histories of science, but also to realize the message that Dhruv just gave, which is the connected nature of what it is. And I think we bring different tools when we come from the humanities and social sciences to the situation. And I think, in school, we used to have this exercise called critical appreciation. And I think we forget that. We forget that very quickly after we leave school. And critical appreciation means you appreciate with a critical eye. And I think that critical appreciation of science needs to be inculcated as a skill, as a mental skill, as an intellectual skill in students of no matter what discipline. It really doesn't matter what discipline, what profession you practice, but you need a critical appreciation, like you need that for art, like you need that for, and I include music in that. You also need that for science in the public domain.
Thank you, Jahnavi. With that, I thank our panelists, Jahnavi, Dhruv, and Hari, for joining us today. I feel we have just been able to scratch the surface of this discussion today, history of science, which is a fascinating journey from the past towards shaping the future. I hope that these conversations will continue and we will meet again at another table. I thank you once again for spending your evening with us. I thank everyone for tuning in and spending your Sunday time with us.
Hey!